Nearly 5 decades after leaving Earth, Voyager 1 continues its incredible voyage through the darkness beyond our solar system. What began as a mission expected to last only a few years has become one of the greatest engineering and scientific achievements in human history. When NASA launched Voyager 1 in September 1977, its primary goal was to explore the giant planets Jupiter and Saturn. Thanks to a rare alignment of the outer planets, engineers used powerful gravitational assists that accelerated the spacecraft to speeds impossible to achieve using rockets alone. The mission quickly exceeded every expectation. Voyager revealed Jupiter as a far more dynamic world than scientists had imagined. It photographed enormous storms, studied its powerful magnetic field, and helped confirm that Jupiter's moon Io is the most volcanically active world in the solar system. Later, during its encounter with Saturn, Voyager captured breathtaking views of the planet's rings and gathered important data about Titan, whose thick atmosphere hinted at a surprisingly complex environment. After completing these historic encounters, Voyager 1 continued outward on a one-way journey toward the unknown. Attached to the spacecraft is one of humanity's most famous symbols, the Golden Record. Created by an international team of scientists, artists, and engineers, it carries greetings in many languages, music from different cultures, natural sounds from Earth, photographs, and basic scientific information about our planet. The record was never intended as a realistic message to extraterrestrials. Instead, it represents humanity's curiosity and our desire to share who we are with a universe we are only beginning to understand. As Voyager traveled farther from the Sun, it approached one of the most important boundaries in space. For decades, scientists believed the edge of the Sun's influence would mark a dramatic transition between our solar system and interstellar space. In 2012, Voyager 1 became the first spacecraft ever to cross the heliopause, the region where the outward pressure of the solar wind is balanced by the surrounding interstellar medium. Many researchers expected this crossing to produce sudden and dramatic changes. Some predictions proved correct. The density of charged particles increased significantly, confirming that Voyager had entered a new environment beyond the solar wind's dominance. However, one observation surprised scientists around the world. The direction of the magnetic field remained unexpectedly similar to what Voyager had measured inside the heliosphere. Instead of a sharp boundary separating two completely different regions, the spacecraft revealed a much smoother and more complicated transition. Several years later, Voyager 2 crossed the same boundary and detected similar behavior, confirming that the outer edge of the Sun's influence is far more complex than earlier models suggested. These discoveries did not reveal hidden objects or mysterious structures. Instead, they demonstrated that the space surrounding our solar system still contains many unanswered scientific questions. Then, decades into its journey, Voyager 1 faced another unexpected challenge. In late 2023, engineers noticed that although the spacecraft continued responding to commands, the engineering telemetry being transmitted back to Earth no longer made sense. The scientific instruments appeared to function, but the health reports contained corrupted and unreadable information. Because Voyager is nearly 24 billion kilometers from Earth, every radio signal takes more than 22 hours to travel in one direction. A single command requires almost 2 full days before engineers receive a response. Diagnosing the problem demanded extraordinary patience. After months of careful investigation, NASA engineers traced the issue to damaged memory inside the spacecraft's flight data system, the computer responsible for preparing engineering information before it is transmitted back to Earth. Rather than giving up on a spacecraft built in the 1970s, engineers developed an innovative solution. They rewrote portions of the software, relocated critical code into healthy memory, and carefully tested every change using commands that required nearly 2 days for each round of communication. Eventually, readable engineering data began returning once again. The achievement demonstrated something remarkable. Even across interstellar distances, a spacecraft designed almost 50 years ago could still be repaired through careful engineering, mathematical precision, and an extraordinary understanding of systems built generations earlier. Far from being evidence of mysterious forces or unknown signals, the recovery became one of the greatest examples of long-distance spacecraft maintenance ever accomplished. And while headlines often focus on dramatic theories, Voyager's real discoveries continue to come from something even more powerful: careful observation backed by scientific evidence. Although Voyager 1 is now traveling through interstellar space, its scientific mission continues to produce valuable discoveries about an environment no spacecraft had ever explored before. One of its most important instruments measures energetic particles and plasma waves drifting between the stars. These observations help researchers understand how our solar system interacts with the wider Milky Way. Soon after crossing the heliopause, Voyager detected a dramatic increase in galactic cosmic rays, high-energy particles that originate far beyond our solar system. These measurements confirmed that the heliosphere acts like a giant protective bubble, reducing the number of energetic particles that reach the planets inside it. The spacecraft also recorded surprisingly dense interstellar plasma. Instead of finding an almost empty void, scientists discovered that the space between stars contains far more structure than previously expected. Invisible magnetic fields, charged particles, and shock waves constantly reshape this distant environment. Another remarkable discovery came when Voyager detected powerful plasma waves created by massive eruptions from the Sun years earlier. These disturbances traveled across billions of kilometers before finally reaching the spacecraft, proving that solar activity continues influencing space far beyond the planetary region. Each new measurement helps researchers improve computer models describing not only our own heliosphere but also similar protective bubbles surrounding distant stars. Understanding these astrospheres may eventually help scientists evaluate how well other planetary systems are shielded from harmful cosmic radiation. Despite these genuine discoveries, misleading stories frequently appear online claiming Voyager has found alien signals, mysterious structures, or unknown civilizations beyond the solar system. There is currently no verified scientific evidence supporting those claims. NASA and independent research teams continue publishing Voyager's observations through peer-reviewed scientific studies. So far, every confirmed result points toward natural physical processes rather than artificial objects or extraterrestrial technology. The real mystery is not whether Voyager has encountered intelligent life. The real mystery is how little humanity still knows about the enormous region separating one star from another. Every new observation reminds scientists that interstellar space is an active environment shaped by magnetic fields, energetic particles, and forces operating across unimaginable distances. Meanwhile, time is slowly catching up with the historic spacecraft. Voyager 1 is powered by radioisotope thermoelectric generators that convert heat released by the natural decay of plutonium into electricity. These generators have worked continuously since 1977, but their power decreases slightly every year. To extend the mission as long as possible, engineers gradually switch off non-essential systems while keeping the most valuable scientific instruments operating. Mission controllers hope Voyager can continue returning useful information into the 2030s, although its exact lifetime depends on the remaining electrical power and the health of its aging systems. Eventually, the spacecraft's final instrument will fall silent. Its last signal will mark the end of one of the longest scientific missions ever conducted. But Voyager's journey itself will not end. Even after communications stop forever, the spacecraft will continue drifting through the Milky Way for millions of years. Long after today's civilizations have changed beyond recognition, Voyager will still travel among the stars, silently carrying the golden record attached to its side. That record remains one of humanity's most symbolic achievements. It contains greetings spoken in many languages, music from cultures around the world, sounds of nature, photographs of Earth, and scientific information describing our home planet. The chances of another civilization ever finding it are extremely small, but that was never its primary purpose. Instead, it represents humanity's curiosity, creativity, and willingness to reach beyond the known. Today, the search for life elsewhere continues through advanced observatories such as the James Webb Space Telescope, powerful radio telescopes, and future missions designed to study potentially habitable worlds. If evidence of extraterrestrial life is ever discovered, scientists expect it will come through careful observations, repeated measurements, and independent verification, not through speculation or sensational headlines. Voyager 1 has never transmitted alien messages or discovered hidden structures beyond the heliopause. Yet its mission remains extraordinary because it proves something even more inspiring. Human knowledge advances through patience, precision, and exploration. Every faint radio signal arriving from nearly 24 billion kilometers away expands our understanding of the universe a little further. Voyager's greatest achievement is not simply the distance it has traveled. It is the reminder that curiosity can outlive generations, technology can exceed expectations, and humanity's desire to explore will always carry us beyond the next horizon. As Voyager continues its silent voyage through the darkness between the stars, it stands as a lasting symbol of one simple truth. The universe still holds countless mysteries, and every journey into the unknown begins with the courage to take the first step.